Hello everyone, am I audible to you all? आवाज आ रही है आपको मेरी? Okay, great, good. So, hi everyone, my name is Ashish, and today we are going to discuss about the interview preparation for AI specifically. Not only AI, but AI, machine learning, deep learning, and agentic AI. Okay, so we'll see which kind of questions can be asked, and mainly we'll divide this whole thing into these main set of questions. Okay, what is AI, what is generative AI, and how it is different from traditional AI. अब इसी के अंदर एक मशीन लर्निंग का कॉन्सेप्ट भी आता है, तो मशीन लर्निंग कैसे अलग हो गई. देन हाउ डू LLM वर्क्स, एंड बिफोर जंपिंग इनटू LLMs वी फर्स्ट नीड टू नो क्या जनरेटिव एआई का पार्ट है LLMs, और जनरेटिव एआई इज द होल LLM. डू वी हैव एनीथिंग एल्स अपार्ट फ्रॉम LLMs इन जनरेटिव एआई एज वेल और नॉट. तो ये कुछ एक बहुत ही बेसिक क्वेश्चंस हैं जो आपको आने चाहिए फर्स्ट ऑफ ऑल. देन व्हाट इज रैग, ये बहुत ही इंपॉर्टेंट टेक है जेनी के अंदर, एजेंटिक एआई के अंदर, जहां पे बहुत ही बड़े नॉलेज बेस से अगर आपको कोई आंसर निकालना है, दैट्स समथिंग वी शुड बी यूजिंग. सो रैग इज ऑल्सो एन इंपॉर्टेंट टॉपिक, वी आर गोइंग टू डिस्कस अबाउट दैट. व्हाट इज रैग एंड हाउ टू यूज इट एंड व्हेन टू यूज इट. हर एक प्रॉब्लम का सोल्यूशन रैग नहीं है. So we'll see when to use a RAG. Not only when to use a RAG, there is also a concept of fine tuning the LLMs. When we need to fine tune the LLMs, that's also a very important concept. And then what is agentic AI? How agentic AI is different from traditional generative AI. So these are going to be the main questions that we are going to answer. कि इनके आसपास के क्या सवाल बन सकते हैं. विल डिस्कस द होल फ्लो एंड देन विल जंप ऑन हाउ एग्जैक्टली यू कैन गेट अलॉन्ग विद इट. Okay, and in between, if any one of you has any doubt at any point of time, do let me know. Okay, I'm continuously looking at the chat, so do give me a yes. Should we go ahead? Okay, so now the first thing that we are going to discuss is this. So this is a map that all of you guys might have seen somewhere. Okay, कि हमारे पास में सबसे ऊपर आता है AI, then we have machine learning, then deep learning. Inside deep learning we have the concept of NLP and computer vision. Okay, इसके अलावा इसके अंदर कुछ और भी algorithms हो जाती हैं. इसके अंदर है generative AI, and inside that we have the concept of agentic AI. So now mainly if I talk about कि जो भी बड़े tech advancements हो रहे हैं, they are right now moving towards the Gen AI agentic AI side. But if you look at the whole diagram, agentic AI, Gen AI are the subset of deep learning, which is a subset of machine learning, which is a subset of AI. So this is a very small subset of AI that has the capability to revolutionizing a lot of different fields. Okay, so now the thing is, first question, what is AI? AI, as you can suggest, it's artificial intelligence. What is intelligence? Intelligence is nothing but how we behave, how we human being behave. इंटेलिजेंस को यूजुअली ह्यूमन बीइंग के साथ में ही मेजर किया जाता है और रेफरेंस लिया जाता है, बट इट शुड नॉट बी लाइक दैट बिकॉज नॉट ऑल द ह्यूमन बीइंग्स आर इंटेलिजेंट. बट इंटेलिजेंस का सीधा सा मतलब होता है, इफ आई एम गिविंग यू अ सिचुएशन, यू कैन हैंडल दिस सिचुएशन, दैट्स इट. यू कैन मेक अ करेक्ट डिसीजन. It's not about just making the decision, it is about making correct decisions. So any AI algorithm that can mimic this behavior of making correct decision given any situation, they are AI algorithms. Okay, let's take a very simple example. ये एक गेम है जो हम सब लोगों ने कहीं ना कहीं कभी ना कभी खेली होगी. दिस इज द गेम ऑफ मेज. Okay, and in this game, this is the starting point, that is the ending point, and in between you can see these are the boxes, these are the paths. तो आपको यहां से यहां तक पहुंचना है. इसको आप एक ना 2D लिस्ट की तरह इमेजिन करो. सो अगर आपको यहां से लेके वहां तक पहुंचना है, सो व्हाट यू कैन डू इज, इसमें कुछ एक आपके जैसे प्रोग्रामर्स होंगे, कुछ एक मेरे जैसे प्रोग्रामर हो सकते हैं. सो मेरे जैसे प्रोग्रामर्स क्या कर सकते हैं कि मैं एक काम करता हूं, मैं इसे हैंड कोड कर देता हूं. हैंड कोड का क्या मतलब है? आई नो दैट टू सॉल्व दिस मेज आई नीड टू टेक 4 स्टेप्स फॉरवर्ड, then take 4, 5, 6, 7 steps at the left, and then I need to keep on doing it. तो मैं इसमें करूंगा क्या, मैं सारे स्टेप्स हैंड कोड कर दूंगा कि जो भी मेरा पाथ बनेगा उसको मैंने कर दिया हैंड कोड. लाइक दिस इज द एग्जैक्ट थिंग दैट यू नीड टू डू. क्या इससे प्रॉब्लम सॉल्व हो जाएगी? द आंसर इज यस. So what I'll do, I'll find the solution manually, then I'll say take 4 step forward, 5 step left, 5 step forward, and so on, and I can reach the maze. This is the solution. Undoubtedly this is the solution that will work. पर इसमें सबसे बड़ी दिक्कत क्या आती है कि solution तो मिल गया मुझे, मैंने कोड लिख दिया, but what if I'm changing the maze? Now my algorithm, my code that I have written, if it is just a basic solution that will solve only that specific maze, क्या मैं उसे AI कह सकता हूँ? It's not at all an AI. Okay, so the best algorithm that I would say it as an AI is the one that can solve the situation even if I'm changing the maze multiple times. Okay, if there is a solution, the solution should be found. Okay, so this is how these are some of the basic examples of AI algorithm. AI का मतलब सिर्फ machine learning, deep learning नहीं होता है. These are also the kind of algorithm that comes under that. इस algorithm को कहा जाता है backtracking. As you can see, the algorithm is finding the path, and from here exactly it went into this path. और इस path से इसे solution नहीं मिला, then it went back and taken this path. And here as well, it's not able to find the path, so it will backtrack and eventually reach to the solution. So this is also a kind of algorithm that comes under AI. Okay, और इस algorithm को data की भी जरूरत नहीं पड़ती है, that we need if I'm talking about machine learning based solutions. So AI is any set of algorithm that may or may not require data and trained on data, means may or may not require data but act intelligently. They are traditional AI algorithms. अब AI के अंदर ही कुछ एक algorithms आती हैं जो data पे train होती हैं, which comes under machine learning. Okay, अब मशीन लर्निंग के अंदर भी बहुत सारे एल्गोरिथम्स आ जाते हैं. इसी के अंदर कुछ एक पार्ट आते हैं जो कि ह्यूमन ब्रेन से इंस्पायर होके एल्गोरिथम बनाते हैं, ह्यूमन ब्रेन से इंस्पायर होके मॉडल्स बनाते हैं. दोज आर द पार्ट दैट कम्स अंडर डीप लर्निंग. ओके, अब डीप लर्निंग के आर्किटेक्चर्स को ही अगर मैं लैंग्वेज पे, टेक्स्ट डेटा पे अप्लाई कर दूं, दैट फील्ड इज कॉल्ड एज एनएलपी. इसी आर्किटेक्चर को अगर मैं इमेज बेस्ड या वीडियो बेस्ड डेटा पे अप्लाई कर दूं, दैट्स कंप्यूटर विजन. दैट्स इट. Deep learning is inspired from human brains. Okay, that's why it is also called as neural networks. Okay, now here comes the main concept. How generative AI is different. Now traditionally AI algorithms का काम क्या था? Be it AI, be it machine learning, be it deep learning. These algorithms are designed to predict something. Might be predicting stock price of tomorrow, might be predicting if the person has a tumor or not, or that tumor is cancerous or not, or might be what should be the next movie you are going to watch, what is the next product you are going to most likely buy, what is the next article you are going to read, what is the next course you are going to purchase. All these kind of things comes under AI where we are predicting something. हम next move क्या हो सकता है उसको predict करने की कोशिश कर रहे हैं, right? But generative AI, when Gen AI algorithm comes into play, they have changed the architecture, they have changed the whole scenario. Gen AI algorithms में क्या कहा कि will now predict, will not just predict, we will generate something new, right? Earlier traditional algorithms we might have models और AI model that can classify कि ये जो picture है, picture के अंदर camera है, phone है, softbox है, क्या क्या है, right? They can classify, but they cannot generate a new image. Traditional, if I'm talking about Netflix recommendation system, it can recommend you this the next movie you are going to watch, but that model cannot generate the script of a new movie, cannot generate a new movie, cannot generate new images, cannot generate new arts, cannot write new articles, right? These algorithms were predictive in nature, but Gen AI algorithms are generative in nature. They are working on the same principles of deep learning. They are still using neural networks, but it all changed when a new terminology, a new architecture comes into play that's called as transformers. अब ट्रांसफॉर्मर का एक बहुत ही सिंपल सा फंडा ये है कि पहले क्या होता था, जो न्यूरल नेटवर्क्स थे, न्यूरल नेटवर्क को अगर मैं टेक्स्ट डेटा दूंगा, दे आर नॉट स्मार्ट इनफ दैट दे कैन रिमेंबर लॉन्ग सीक्वेंसेस। इसमें आप ऐसी दिक्कत समझो कि अगर मैं आपको एक लाइन लिखने बोलूं, you might write it, okay, but if I'm asking you that you need to write a whole paragraph, so issue is if you have only the memory of 30 words, after 30 words you will start forgetting whatever is being said earlier. तो 30 वर्ड्स बोलने के बाद में आप पुरानी बात भूल जाते हो। तो इससे होगा क्या, अगर आप पैराग्राफ लिखने जाओगे आप कुछ रैंडम ही बना दोगे, यू स्टार्ट फ्रॉम समथिंग एंड यू विल एंड अप विद समथिंग एल्स। these are one of the this is one of the biggest problem with deep learning, that it cannot keep track of long sequences, okay, especially in terms of text, okay, and images as well. So deep learning का एक special architecture design किया गया on the principle of attention mechanism, okay. अब attention mechanism में एक ऐसा mechanism लगाया, एक ऐसा mechanism है that can also keep track of very long sequences. पहले जो डीप लर्निंग के मॉडल जो स्ट्रगल करते थे 30 वर्ड 40 वर्ड्स पे, नाउ दीज मॉडल्स, ट्रांसफॉर्मर बेस्ड मॉडल्स और अटेंशन मैकेनिज्म कैन पुट अटेंशन ऑन व्हाट आर द थिंग दैट वी नीड टू पुट मोर अटेंशन ऑन। अब इससे हुआ क्या, नाउ वी हैव मॉडल्स दैट कैन रिमेंबर इवन होल बुक, दैट कैन pinpoint, put attention on these are the words that are important for me to generate the next thing, okay. attention mechanism से ये अटेंशन मैकेनिज्म इज द बैकबोन ऑफ ट्रांसफॉर्मर्स। फिर ट्रांसफॉर्मर आर्किटेक्चर आया जिसमें उन्होंने कहा डीप लर्निंग का हम ज़्यादा यूज़ नहीं करेंगे, हम पूरी की पूरी चीज़ों को सीधा मीन्स हम सीक्वेंशियल डेटा को सीधा न्यूरल नेटवर्क्स पे ले जाएंगे, ओके। सो दिस इज व्हाट दे हैव डन इन अटेंशन मैकेनिज्म। सो अटेंशन मैकेनिज्म की वजह से वी हैव अ न्यू फील्ड दैट्स जनरेटिव एआई, ओके। अब ऐसा नहीं है सिर्फ अटेंशन मैकेनिज्म है जनरेटिव के अंदर या सिर्फ ट्रांसफॉर्मर्स है, वी हैव लॉट ऑफ अदर आर्किटेक्चर एज वेल, बट मेन ब्रेक थ्रूज जो हमें मिला वो मिला अटेंशन मैकेनिज्म या ट्रांसफॉर्मर्स की वजह से। बिकॉज ऑफ दैट वी हैव मॉडल्स लाइक जीपीटी, okay. Do give me a list of tools that you know are generative AI based, okay. Just give me a list of tools in the chats जो आपको लगता है कि ये generative AI के बेस के हैं, okay. Now the thing is, चलो ठीक है generative AI भी समझ आ गया, these are the algorithm that will not predict but they can generate something new as well, okay. अब generative AI समझ आ गया, transformers एक architecture आया था, उस वजह से generative AI के algorithms आए। So what is LLM then? What is LLM or what are LLMs? LLMs का सीधा सा मतलब है लार्ज लैंग्वेज मॉडल्स। लार्ज लैंग्वेज मॉडल्स क्या होते हैं? लार्ज लैंग्वेज मॉडल का सिंपल सा फंडा है, जैसे हम चैट जीपीटी यूज करते हैं। चैट जीपीटी क्या करता है, टेक्स्ट इनपुट में लेगा, टेक्स्ट आउटपुट में दे देगा, राइट। आपने सवाल पूछा, आपको जवाब मिला टेक्स्ट में, राइट। सो दिस इज ट्रेडिशनल LLMs, large language models. Why large? Because they are trained on massive amount of data. आप किसी भी टॉपिक पे सवाल पूछोगे आपको जवाब मिलेगा। क्यों मिलेगा? क्योंकि उस मॉडल को हर टाइप के डेटा पे ट्रेन किया गया है, राइट। दैट्स करेक्ट। कृष्णा इज सेइंग ChatGPT DeepSeek, ओके। ChatGPT इज नॉट द LLM, ओके। अगर आप कहो कि मैं आपसे बात कैसे कर पा रहा हूँ, मैं बात जुबान से कर पा रहा हूँ, राइट। मैं हैंड मूवमेंट से बात कर पा रहा हूँ, पर दिक्कत क्या है कि मैं कहूँ अगर मैं सिर्फ जुबान से बात कर रहा हूँ, इट्स नॉट लाइक दैट। आई एम यूजिंग माई टंग, माई हैंड्स, माई माउथ, बट इवेंचुअली जो कम्युनिकेशन हो रही है वो ब्रेन से हो रही है। माई ब्रेन हैज द नॉलेज, माई ब्रेन हैज ऑल द इंफॉर्मेशन थ्रू विच आई एम कम्युनिकेटिंग, ओके। सो जो मेन पावर है, जो मेन इंटेलिजेंस है वो तो ब्रेन में है ना। सो चैट जीपीटी क्या है? चैट जीपीटी एक बॉडी है, बट इसके अंदर मॉडल कौन सा काम कर रहा है? टू गिव मी नेम ऑफ द मॉडल दैट यू आर टॉकिंग अबाउट। यस, डीपसीक के अंदर, डीपसीक इज द नेम ऑफ द मॉडल एज वेल, डीपसीक R1 है। चैट जीपीटी की बात करूं, चैट जीपीटी इज एन एप्लीकेशन, इट्स अ वेबसाइट वेयर यू कैन गो एंड टॉक टू द मॉडल्स। और वो मॉडल कौन से हो गए? GPT-3 हो सकता है, GPT-4 हो सकता है, GPT-5 हो सकता है, राइट। 5.1 है, 5.2 है, दीज आर दी LLMs, ओके। अब LLM का क्या फंडा होता है? LLM ओनली वर्क्स ऑन टेक्स्ट, इसी वजह से इन्हें लैंग्वेज मॉडल बोला जाता है, राइट। But for example, DeepSeek है, Gemini है, they will take text as an input, text as an output. You might be thinking, sir मैंने तो मैंने text लिखा था, LLM ने code दे दिया, तो क्या वो भी LLM ही रहेगा? Yes, because code क्या है? Code भी तो text ही है ना, right? उसका language थोड़ी change होगी, even language भी change हो रही है, still it's a text, right? So in that particular scenario, LLMs are something that works on text data. Okay, we'll take text as an input, text as an output. But we also have some special kind of models. They are called as omni models or multi models, multi model modality. Okay, उसका क्या मतलब होता है? अभी जो हमारे पास models है, that will take text as an input, text as an output. But we also have models that can take text as an input and generate an image. So how come models generate images? ये तो हमने सिखाया ही नहीं था, LLMs का ये तो काम ही नहीं था. सो व्हाट विल हैपन इन दैट केस कि हम मॉडल्स को ट्रेन ही टेक्स्ट और इमेजेस के पेयर्स में करते हैं. सो नाउ द मॉडल, we also have a model that will take text as an input and generate image. Now shall I do one thing? I'll make two models. One of them is for text to text, another one is for text to image. Now the issue is, whenever I am asking the question, तो उस क्वेश्चन में इमेज जनरेट होनी है. फॉर एग्जाम्पल अगर मैं चैट जीपीटी में जाऊं तो उस क्वेश्चन पे क्या इमेज जनरेट होनी है, मुझे आंसर देना है. अब ये कैसे डिसाइड होगा? क्योंकि अगर अब मैंने इमेज जनरेटर मॉडल को दे दिया, वो तो इमेज जनरेट कर देगा. एंड इफ आई एम गिविंग द सेम टास्क टू a language model that is textual in nature, so it will give me an answer in text. So how should I cross verify that whatever question I am asking should be given to the right model? So in that case, we can have omni models that can take text as an input, and based on the input it will decide कि इसकी इमेज जनरेट करनी है या ऑडियो जनरेट करनी है या टेक्स्ट में आंसर देना. So we have omni model modality as well, and it's not mandatory that we need to give the input as a text only. We can give the input as an image, we can give the input as text, we can give input as an audio, we can give any type of input to the model. Okay, so LLMs सारी दुनिया नहीं है, LLMs जनरेटिव एआई नहीं है, LLMs एक पार्ट है. LLMs के अलावा भी जनरेटिव एआई एल्गोरिथम्स हैं that are omni model in nature. Okay, और सिर्फ LLMs या omni models ही नहीं, we also have models, for example diffusion model. Diffusion model is also generative in nature, वो भी नई images generate करता है और उसका तो architecture भी transformer नहीं है. So generative AI has a lot of other things apart from LLMs. LLMs एक छोटा सा सब पार्ट है. मैं यहाँ पे LLM लिख सकता हूँ छोटी सी जगह पे. This is what generative AI, this is what LLMs are. LLMs are not generative AI. अभी हो क्या रहा है कि GenAI के अंदर भी एक छोटा सा पार्ट है LLM that has the capability to revolutionizing a lot of industries, that it is doing as well. Okay, so अगर आपको सबसे इंटरेस्टिंग पार्ट ऑफ AI के अंदर घुसना है, सबसे इंटरेस्टिंग पार्ट, that is this part, जनरेटिव एआई. ओके, जनरेटिव एआई एंड एजेंटिक एआई. इसका रीजन ये है क्योंकि मशीन लर्निंग, डीप लर्निंग ये समंदर है. इट हैज अ लॉट ऑफ थिंग्स टू लर्न, लॉट्स एंड लॉट्स ऑफ थिंग टू लर्न, एंड यू आर ऑल्सो बिल्डिंग द मॉडल्स फ्रॉम स्क्रैच. बट यहां पे क्या है, बिकॉज डेटा इज सो ह्यूज, डू यू थिंक यू कैन ट्रेक जीपीटी लेवल मॉडल एट योर होम with just thousands of rupees in your pocket? No. It costs millions, multi-million dollars to train model like GPT. Okay, so there are very less number of companies building their own LLMs, building their own GenAI models. So अब इससे होगा क्या कि लोग मॉडल बना रहे हैं, हम क्या करेंगे, हम उन मॉडल्स को यूज कर लेंगे. कंपनीज ओपन सोर्स कर देती हैं उन मॉडल्स को. अगर ओपन सोर्स नहीं भी है, वी ऑल्सो हैव सम क्लोज सोर्स मॉडल दैट वी कैन कम्युनिकेट विद थ्रू देयर APIs और थ्रू देयर पोर्टल और थ्रू देयर टूल्स और प्लेटफॉर्म. So उससे होगा क्या, I have the capability to use those models with very less of a cost, because training those models is computationally really expensive and financially really expensive. So there are a very less number of companies building their own GenAI models, but there are a lot of companies that are using these GenAI models for their use case. Okay, so ये हो गया GenAI का part. GenAI have algorithms that can generate something new, probably a text, probably write article, probably images, probably audio, probably video, probably apps, right? नाउ द थिंग इज हाउ एजेंटिक एआई इज डिफरेंट. अब एजेंटिक एआई में ऐसा क्या हो गया? नाउ if I go to chat gpt, what will happen? I'm not going to chat gpt but just want to tell you what will happen. If I'm going on chat gpt and asking, tell me the current scenario between Iran Iraq war, so वो क्या करेगा? वो इंटरनेट पे सर्च करके आपको आंसर देगा. ओके. जब भी एलएलएम्स को ट्रेन किया जाता है, मॉडल्स को ट्रेन किया जाता है, मॉडल को एक स्पेसिफिक सेट ऑफ डेटा पे ट्रेन किया जाएगा, राइट? फॉर एग्जांपल इफ मॉडल इज ट्रेन टिल द डेटा ऑफ 2025 दिसंबर, सो 2025 दिसंबर के बाद जो भी चीजें हुई हैं, क्या मॉडल को पता है? मॉडल को नहीं पता है. इसको बोला जाता है नॉलेज कट ऑफ. एवरी मॉडल हैज अ नॉलेज कट ऑफ, राइट? सो हाउ द मॉडल हैज द एबिलिटी टू गिव मी द आंसर. अब इसके लिए कॉन्सेप्ट क्या होता है कि मान लीजिए यू आर, मीन्स नॉट यू आर, बट मान लीजिए कोई एक शख्स है हु इज इन जेल. ओके, हु इज इन जेल फ्रॉम 2010. ओके, and he is in complete isolation. He don't have newspapers or any communication to the outer world. So after, let's suppose 15 years or 16 years, when he came out of the jail, अब उनसे अगर पूछा जाए कि बताइए आज प्रधानमंत्री कौन है इंडिया, क्या वो बता पाएगा? The person might not able to tell you, right? But if I'm giving them a paper, not blank paper, but I'm talking about newspaper, or giving them internet access or giving them any kind of additional resources, so shall the person, if the person has the knowledge, if the person can read and is educated enough that the person know the concept of prime minister, so the model can give you the answer, that person can give you the answer. बिल्कुल ऐसे ही नॉलेज कट ऑफ काम करती है. अगर मेरा मॉडल 2025 तक ही ट्रेंड है तो होगा क्या? मॉडल आंसर दे ही नहीं पाएगा. पर फन यहाँ पे आएगा कि 2025 तक तो डेटा पे ट्रेन है, तो उसे प्राइम मिनिस्टर का कॉन्सेप्ट तो पता होगा, उसे इंडिया नाम की एक कंट्री है ये भी पता होगा, राइट? सो नाउ if I'm giving the ability to the model that it can search the internet in real time, probably go to Google, take first 5 pages, scrape the data, and based on this data try to give the answer. Do I have the chances that I'll get the answer of the question? The answer is yes. अब क्या इसके लिए मुझे मॉडल को दोबारा ट्रेन करना पड़ा है? नहीं. इट इज जस्ट लाइक मैं चैट जीपीटी से पूछ रहा हूं, डायरेक्ट वो आंसर नहीं दे पाएगा बिकॉज इंटरनेट का एक्सेस नहीं है. सो व्हाट आई एम डूइंग, आई एम कॉपी पेस्टिंग अ होल आर्टिकल of recent news on who's the president of India, prime minister of India, copy pasting that article to ChatGPT. Now, can ChatGPT give me the answer of that? The answer is yes. This is exactly what agentic AI is. Agentic AI में क्या होता है? Now I have a model to which I am asking a question. Now model is not totally dependent on the existing knowledge that the model has. Model has some additional tools as well that it can access. Tools like searching the internet, or going to your GitHub to fetch the notebook, or going or pushing something on your uh, on your feed, or writing something or downloading something on your system, or creating a new file, or writing a whole project. So to the LLM, I am giving some additional permissions, or it has the knowledge of some additional tools. अब उस एडिशनल टूल से क्या होगा? नाउ माई मॉडल दैट इज अर्लियर जस्ट अ ब्रेन is now having hands, right? Because traditional LM is just a brain, जिससे हाथ हम बस कम्युनिकेट कर सकते हैं. हम क्वेश्चन पूछेंगे वो आंसर दे देगा, क्वेश्चन पूछेंगे हो सकता है इमेज जनरेट कर दे, हो सकता है ऑडियो आउटपुट में दे दे, बट इट्स नॉट हैविंग द ability that it can go to your desktop, create a folder, and inside that folder write something. It's not having that ability. So से होगा क्या? Agentic AI is LLMs plus tools. ओके, LLMs मीन्स ट्रेडिशनल LLM जो हमारे पास में है, पर उसको हमने एक्स्ट्रा कैपेबिलिटी दे दी कि अब आप इंटरनेट सर्च कर सकते हो, राइट? सो इवेंचुअली इससे होगा क्या? वी कैन हैव द कॉन्सेप्ट ऑफ एजेंटिक एआई. ओके, अब हम थोड़ी और चीजों को समझने की कोशिश करते हैं कि एग्जैक्टली क्वेश्चन किस किस टाइप से आ सकते हैं. ओके, नाउ इफ आई एम गोइंग टू, आई वुड से दीज आर द न्यूरल नेटवर्क्स. सो एक तो बहुत ही सिंपल से क्वेश्चन आ सकता है कि फॉर एग्जाम्पल एक रैक क्या होता है। ओके, रैक का ये थोड़ा आर्किटेक्चर है, पर इसको एक बार के लिए साइड में रखता हूं। अब व्हाट इज एआई आपको क्लियर हो गया, व्हाट इज जनरेटिव एआई इट्स क्लियर, हाउ डू एलएलएम वर्क्स दैट्स आल्सो समवॉट क्लियर टू यू। ओके, नाउ हाउ डू एलएलएम वर्क्स, इसके लिए मैंने आपको बताया था एलएलएम वर्क्स ऑन ट्रांसफॉर्मर बेस्ड आर्किटेक्चर। ओके, तो उसके लिए आपको करना क्या पड़ेगा, आपको ट्रांसफॉर्मर के बारे में थोड़ी बहुत नॉलेज होनी जरूरी है। ओके, अदरवाइज आप कोई पास में कोर कॉन्सेप्ट नहीं होंगे। ओके, सो व्हाट आई वांट फ्रॉम यू गाइस इज मेक श्योर योर फंडामेंटल्स आर क्लियर। मैं ये नहीं कह रहा ट्रांसफॉर्मर की आपको सारी सब चीजें आनी चाहिए, पर आपको ट्रांसफॉर्मर का एक बेसिक आर्किटेक्चर तो पता हो कि ट्रांसफॉर्मर होता क्या है, इनपुट में क्या आता है, आउटपुट में क्या आता है, किसने इन्वेंट किया था। राइट, देयर इज अ फेमस पेपर, इफ एनीवन कैन नेम इट दैट वुड बी ग्रेट। राइट, डू लेट मी नो इन द चैट्स if you guys have know in which paper transformer was introduced. Okay, now what is RAG and when to use it. Okay, अब RAG is a very very important concept. अब RAG के अंदर होता क्या है कि लेट सपोज अगर मैं चैट जीपीटी से पूछूं कि मेरी कितनी लीव्स बची हैं, क्या बता पाएगा, नहीं बता पाएगा। मुझे करना क्या पड़ेगा, मुझे मेरे पोर्टल का एक्सेस देना पड़ेगा, हो सकता है मुझे जोहो का एक्सेस देना पड़े। Then the model has the ability to search, to go to my profile and give me the answer. Okay, so ये तो हो गया agentic AI based system जहां पे I am giving some additional resources to the LLM. Now let's suppose I want to make a chatbot. Okay, और वो chatbot क्या करेगा, जो भी मैं सवाल पूछूं मुझे उसका एक आंसर मिलेगा, कोडिंग क्वेश्चन होना चाहिए। ओके, फॉर एग्जांपल इफ आई एम आस्किंग द एलएलएम व्हाट आर द मेन functions that we have in python, okay, or what are decorators in python, okay, write a sample code to run decorators in python। तो उसके लिए क्या होगा, मैं क्या कर सकता हूं, मैं चैट जीपीटी की एपीआई यूज कर सकता हूं, आई सेंड द रिक्वेस्ट टू चैट जीपीटी, आई गेट द आंसर। राइट, क्या इसके लिए मुझे रैक की जरूरत है, नो मुझे क्या चाहिए, एक बेसिक एपीआई कॉल, आई सेंड रिक्वेस्ट, आई गेट द रिस्पॉन्स, दैट्स इट। पर इससे ऊपर क्या हो सकता है कि लेट सपोज मुझे एक जेनरिक आंसर नहीं चाहिए, मैं चाहता हूं कि गीक्स फॉर गीक्स पे कोई भी आर्टिकल हो अगर उसके आसपास का जो भी मैंने सवाल पूछा है, तो उससे क्या होगा, आई सेंड रिक्वेस्ट और वो मेरे एग्जिस्टिंग नॉलेज बेस में चेक करेगा। मेरे पास जो भी हजारों आर्टिकल्स है, यूजुअली 2 लाख के करीब आर्टिकल्स है हमारे पास, सो इन ऑल दोज 2 लाख आर्टिकल्स दैट क्वेश्चन विल बी सर्च, और जो भी मोस्ट रिलेवेंट आर्टिकल्स हैं वो मेरे पास में आंसर में आ जाए। अब ये कैसे किया जाए, क्योंकि पहले चैट जीपीटी क्या कर रहा था, वो जेनरिक आंसर दे रहा था जो उसे पता है। अब मैं क्या चाहता हूं कि मेरे पास जो एग्जिस्टिंग आर्टिकल्स हैं उनके बेस पे आंसर आए। अब उस केस में क्या होगा, अब इस केस में क्या मैं सारे के सारे आर्टिकल चैट जीपीटी को दे दूं और उसके बाद में चैट जीपीटी हर बार क्वेश्चन पूछ के बताता रहेगा। ऐसा नहीं कर सकते हैं, क्योंकि अगर आपको पता हो एलएलएम्स में एक कॉन्सेप्ट होता है टोकन्स नाम का। ओके, अब टोकन्स क्या होते हैं, एनीवन, व्हाट इज अ टोकन, डू लेट मी नो इन द चैट्स, व्हाट इज अ टोकन। टोकन का सिंपल सा कॉन्सेप्ट होता है कि जब भी आई एम आस्किंग एनी क्वेश्चन टू दी एलएलएम, फॉर एग्जांपल इफ आई एम राइटिंग व्हाट इज योर नेम, उस केस में होगा क्या, व्हाट इज योर नेम, मॉडल 4 वर्ड्स को एज एन इनपुट लेगा। एवरी वर्ड इज यूजुअली कॉल्ड एज अ टोकन, एंड मॉडल ने अगर आंसर दिया है माई नेम इज चैट जीपीटी, 4 वर्ड इज द आउटपुट। ओके, इनपुट टोकन कितने हो गए, व्हाट इज योर नेम 4 टोकन्स, आउटपुट कितने हो गए, माई नेम इज चैट जीपीटी 4 टोकन्स। मॉडल जो भी होते हैं ना, ये सब मॉडल्स आपको चार्ज करते हैं पर टोकन बेसिस पे। अगर आप ओपन एआई का कोई मॉडल यूज करना चाहते हो और यू आर यूजिंग एनी मॉडल फ्रॉम जेमिनी, वी नीड टू यूज देम बेस्ड ऑन पर टोकन बेसिस। ओके, एंड लेट सपोज आपने सारे के सारे आर्टिकल मॉडल को दे दिए, सारे आर्टिकल आई हैव लेट सपोज 200,000 आर्टिकल्स एंड एवरी आर्टिकल इज सपोज 100,000, लिटरली हैव मिलियंस ऑफ मल्टीपल मिलियंस और समवेयर अराउंड बिलियंस, आई एम नॉट श्योर अबाउट द नंबर, बट दैट्स अ वेरी ह्यूज नंबर दैट विल कॉस्ट अ लॉट फॉर मी टू फिट इट टू द मॉडल, क्योंकि कॉस्टिंग बहुत ज्यादा हो जाएगी। क्योंकि इनपुट टोकन्स अगर मैंने 10 मिलियन डाल दिए या 50 मिलियन डाल दिए, 50 मिलियन पहली बात तो डाल नहीं पाऊंगा, क्योंकि हर एक मॉडल की एक लर्न करने की, अटेंशन स्पैन की कैपेसिटी होती है, जिसे हम कॉन्टेक्स्ट विंडो बोलते हैं, right? So in that context window, main issue is, if let's suppose my model has a context window of a paragraph, I cannot give them two paragraphs because model will start forgetting whatever is being said earlier. Model will only understand whatever is being said in the last paragraph. Okay, and in the exact same way, these context windows are usually in a very huge number. सिर्फ paragraph नहीं होती, it usually in couple of thousands tokens. We also have model that has million context window, million token context window, right? So I don't have the option to fit in all the articles on the context window of the model. First of all, it's computationally expensive. Second thing, we don't have that huge of a model. So what we can do, we can make a RAG based system there. And in RAG based system, what will happen is basically it will go something like this. So as I've told you, if this is the question, I cannot directly give it to an LLM because it will give you a very generic answer. In the second case, if I'm giving all the articles to the LLM and then asking the question, I cannot fit them because we don't have that huge of a model. So what I can do, I will use something called as this. So I'll take all the articles. For every article, I'll generate their embeddings. So those who know about RAGs, they might have also heard about something called as embedding. अब embedding क्या होती है? Embedding is nothing but a numeric representation of the whole article or the whole text that we have given. So what we can do, for every article, whatever content is there, I'll generate an embedding of it, which is a fixed size array of numbers, floating point numbers. And eventually what we can do, we can generate this embedding for all the articles. I have 2 lakh articles, I'll generate the embedding for all these articles. Why I'm doing so? So basically I'll have something like this. Okay, so this is the title, this is the content, and this is the embedding that I have. So what I can do, whenever someone is asking any question, whenever a user is asking any question, what will happen? That user, the query that we have, for example, what is AI? For that query as well, we'll generate embedding. Okay. And based on the embedding generated for the question, I'll find the similar embeddings. If I have 2 lakh articles, so in all those 2 lakh articles, I'm going to compare my embedding with all these other embeddings. And these are just simple similarity search I'm doing. So what I'll get the most similar embeddings. So what I can do, I can take top 50 similar embeddings, and I know if these are the top 50 similar embeddings, I also have their articles. So now I know that to get the answer of this question, I know in which article I need to search for, right? So to reach to the most similar articles, we use the concept of vector embeddings. Okay, and once we have those things, we'll get the chunks of it. Chunk is nothing but the content written in those most similar articles. Okay, there is a very important concept. Even the people who know RAG also might have missed this concept. There is the concept of re-ranking. Okay, so basically what I'll do, I'll take 50 articles, and all those 50 articles, I will take one article at a time, and along with that I'll also write the query, the actual question, right? So if I'm taking the question along with all the articles one by one and giving it to re-rank model, the re-rank model will go to the content of each and every article of top 50 and find only the top 5. It is just like a second level search. First level is searches through embeddings. Second level search is from re-rank model. And eventually I'll have top 5 articles where I'm pretty sure I'll get the answer. And then I'll give all these articles along with the question to the LLM and I'll get the answer. Okay, this is by far the best technique that we use to go for very huge knowledge base, where I have a huge content and I want the answer among that content, not a generic answer. Okay, so in that case, we can use a vectored RAG. Okay, so make sure you know about embeddings, you know about similarity search. How will you find the similarity? There are a lot of similarity matrices that we have, but you need to understand which one you should be using. Chunking basically is, let's suppose my article is very huge. So what I can do, I can divide that article into multiple chunks, 3, 4, 5, 10, 20. Okay, and after dividing them into multiple chunks, I can use those chunks to get it through. Okay, for some people this class might be a little bit detailed technical, because obviously they are not going to ask you very generic questions. Okay, you can get the answer of those generic questions even by asking to ChatGPT as well. Okay, so this class is detailed because this is supposed to be detailed, because they will ask you question related to these details. Okay, because these details only the person who have the knowledge, who write the code, who write all the things by themselves can understand. Okay, let's go for re-rank again. Okay, so in re-rank, eventually what we are doing, for in the beginning we have embeddings and we'll get top 50 articles. But in those articles, in these 50 articles, am I comparing the content of them or just embeddings of them? Am I comparing their content or am I comparing their numeric representations? What am I comparing? I am comparing their numeric representation, which might not be exactly the same as what is written in the article, right? So what I'll do, now I'll do the comparison based on the text written in those articles. So I'll take the question, I'll compare it with the first article, and I'll get a rank, probably 0.9. I'll compare the second question, the same question with second article, get the rank, probably 0.97. Same question, third article, I'll get another rank, and fourth and fifth and so on. And eventually, once I have done it for all of them, what will happen? I will get all these articles, 50 articles, and along with them their rankings. One of them probably 0.97, 0.8, 0.99. So I'll sort them based on the ranking. I'll take only top 5 articles. So this is a second level search that is based on the content written. These embeddings are not taking care of what is written inside it, because I'm just finding the similarities. I hope that is clear now. Is it? And then I'll take the top 50 chunks, re-rank them. So re-rank is another model that we need to use. There is another AI transformer based model usually that has the capability to take the question and the context and find how relevant these two things are. And it will rank the things accordingly. Okay, so this is the traditional approach of a RAG based system. Okay, so inside that, you need to understand how much size of chunking you need to do, which embedding model you should be using, which vector database you are going to use, because eventually when I'm talking about embedding models, there are a lot of embeddings that I have. And embeddings are not like we have 5 numbers, 10 numbers. We have embeddings of 512 size, 1000 size, 2000, 4000 size. So for every article, if I have this huge size of an embedding, it's very difficult to save it in traditional databases. So for that purpose, we use something called as vector DB. So you also need to understand the concept of vector databases. Okay, so make sure you know what are vector databases and how vector databases works. Okay, now the thing is, there is also one more concept, okay, that they might be asking about, that's called as vectorless RAG. This is comparatively new, okay, but this is something that I'm giving it to you so that you will understand it by yourself. Okay, what is vectorless RAGs? Okay, but in vectorless RAG there is only one concept that is different. We don't generate embeddings. We'll directly take the query and do the chunking and directly pass it to the re-rank model. That's it. I'll take the article, directly give it to the re-rank model and get the answer. I am totally replacing the embedding part. What is the drawback of that? If I have a huge knowledge base of hundreds of thousands of articles, so I need to perform re-ranking hundreds of thousands of time. That is computationally really expensive. It will take a lot of time to run. So it's not a scalable approach. It can work great if I have a very small knowledge base, probably a document or so. But for large scale system, still vector databases or RAG based system or vector RAG is still winning. Okay, so those who are saying, sir, vectorless RAG is the future, no, it is not. Okay, it might be for a specific use case, but there are no other approaches that can reach in vectored RAG. Okay, so this is a vectored RAG. Okay, so what is RAG? RAG is just an extra layer on LLMs where if you want the answer from your existing knowledge base, your existing articles, then you can use something called as a RAG based system. In RAG, we have multiple kind of RAGs. Okay, we have vectored RAG, we have vectorless RAG. In vectorless RAG as well, we have a lot of different kind of models you can use for re-ranking. Okay, which chunking technique you are using, how much size of chunk you are using, which embedding model you are using. Okay, how well these embeddings are generated. Okay, all these things are really very important if you want to showcase like this is what I have done. Okay, now the last and the, I would say, the elephant in the room, what is agentic AI? So agentic AI in general, we have already done a discussion that in agentic AI we have traditional LLMs that has the knowledge. Okay, but we are giving them some extra capabilities like they can search the internet, they can go to your GitHub and fetch the repository, they can search the internet, fetch some images, they can go to YouTube and fetch some of the videos, or I will give them a YouTube video, they can summarize that video, or I'll give them some audio and they can revert you the text format of it or generate a PDF. Okay, so all these things are the tasks of agentic AI. So in agentic AI, we have traditional LLMs, but these LLMs has the ability to do some sort of tasks. Okay, for example, uh, let's take a very simple example. Okay, let's suppose this is the query that I'm having. Recent news in AI. If I'm giving it to directly an LLM, let's skip this part for now. If I'm asking this query directly to an LLM that's not having internet access, what do you think you will get as an answer? You will get a random news before the knowledge cutoff, probably an old news of 2025. Okay, so you will get that answer. But if you want your model to search the internet and then give the answer, so what you can do, recent news in AI. So Serper plus scrapping. Serper is a tool that will help you search the internet and give you top 5, top 10 links from Google. Scraping is something that can go to those links and scrape the data from those websites. Okay, so what will happen along with this question? I'm scraping probably top 10 websites or top 5 websites for the questions. And in top 5 websites, I might be having literally 5,000 tokens per web page. So that means if I'm scraping 10 web pages, I'm talking about probably 20,000 tokens. So along with 4 tokens, I'm passing 20,000 tokens and then giving to the LLM. And now if I'm asking the LLM to answer, shall I get the answer of the question? The answer is yes. Because now along with this, I'm searching the internet, going to the internet, downloading top 10 web pages, scraping top 10 web pages, and then along with the scraped articles and the question, I'm giving to LLM and then I'm getting the answer. Will I get a better answer? Will I get a correct answer? Obviously, I will get correct answer. But what's the drawback? Every time, even if I'm asking for like what happened in 1997 in India, okay, or 1992 in India, or 1984 war, or if I'm talking any historic question. So do you think to get the answer of that historic question, we need to search the internet or the LLM already have the answer of that question? Do I need to search the date of birth of Mahatma Gandhi to search the internet and give the answer? Don't you think LLM already have the answer of that? Does this make sense? Because ये कुछ ऐसी knowledge है that LLM already have. the LLM knowledge cutoff. Before that as well, the model is trained on that. Okay, so model has the answer of that. So what we can do, for every question, I cannot search the internet and give the answer. That's a problem. But I should also give the model to decide like if you should search the internet or not. So what we can do, we can make something like this, where I'll have a question, I give it to a model, and the model will decide if the model has the answer of this question or not. Right? If model has the answer of this question, it will give you the answer directly as it is. Right? If it's not having the answer of this question, it will search the internet, scrape top 10 articles or top 5 or whatsoever, then give it to the LLM, probably the same LLM, and then get the response. So this is the flow that we can define, right? Where I have an LLM that will check if I have the knowledge or not. If I have the knowledge, I'll get the response as it is. If we don't have the knowledge of it, we'll send it to a scrapper. This is an additional tool that I have hand coded, and then give it to the data to the LLM and I'll get the response. So this is a simple approach that can solve this issue. But what's the issue with this? What is the issue with this approach? Anyone? There's a huge issue in this. The major issue here is I need to use LLM twice. I need to call the LLM twice, right? But this is what we need to do. We must do it, otherwise it's very difficult for the model to understand. Now, apart from just searching the internet, shall I add some more options here as well? Because this is one tool that I have added, that LLM can decide should we give direct answer or use search. Now, shall I do one thing? Along with searching the internet, shall I also write like searching Airbnbs or searching LinkedIn or searching Naukri.com jobs? So shall I add different tools and let the LLM decide which tool we need to select? So if my question is, tell me the recent AI jobs. So now this LLM can decide, should we need to search the internet or search Naukri.com or search Glassdoor or search GitHub or search what? We are giving this task to LLM so that LLM can decide. So LLM will decide which tool we need to use. So it will go to that tool, fetch the data, and eventually give it to an LLM. You can also make it as a loop. This, and then the data will go back. And it also has some sort of memory so that it can understand what is said earlier. So this was the query. The model has decided we need to use this tool, and this can go back here. And now this model has the knowledge. Earlier the model don't have it. So rather than going for this extra step, we can also go for a backward loop, where rather than having one tool, we can have 10 separate tools and the LLM will decide, and the same LLM can give you the response. This is what Agentic AI is. Literally, this is Agentic AI. To the LLM, I'm just giving some extra capabilities, that rather than giving a direct answer, now you have the option that you can go for a direct answer, or you can use different kind of tools that you want. Okay, this is a very simple approach of Agentic AI, right? And now this is an oversimplified version of it. Okay, rather than going in this direction, it should be in both the directions. But usually what's happening, we have a question, we have a model that is usually a reasoning model that can think and react accordingly. And here I have given them the options of different tools. It's a simplified version. Okay, so the model has the ability to search the links, to find only the top links. It has the option to scrape the data from those links. So some question can be easily answered without going for 10 web pages, but some of them can be answered with just one page. Some of them can be answered directly through the subheadings written on those web pages as well. Okay, so that's something the LLM can decide. Image reader, like if I'm passing an image, the LLM can read the image. PDF reader, or any other kind of tool you want to add, you can integrate all the tools here. So this is a simple architecture where I'll ask a question, I have an LLM. Before answering the question, LLM will decide if the LLM has the answer of this or not. If LLM has the answer, it will give it straight away. If LLM don't have the answer, it will go to the set of tools that it has the access to. Okay, and among all these tools, the LLM will decide which tool I need to use. If LLM think, okay, I need to use search link tool, it can use search link. And if LLM thinks, I think I need to scrape the data of first 10 pages. But to scrape the data, first of all, LLM will decide we need to search the links. So LLM will decide the flow of the execution of these tools as well. Okay, so in Agentic AI system, mainly we have an LLM that will be a reasoning LLM that has smart intelligence into it. The more complex Agentic AI system you want to make, the more higher end models you need to use. The more complex reasoning models you need to use. For example, if you want to make a very simple system like this, you can use Gemini 2.5 Flash, which is not that computationally expensive, means not that financially expensive as well. But if I want to make a code writer that will write very complex codes and that has the ability to search the internet, that has the ability to go to a system and write the code, that can integrate different kind of py files, run the code, test the code, in that case 2.5 Flash might not be the best option. You need to go for 2.5 Pro or Quinn, right, or Opus. Okay, so these are the models that you might need to use. Okay, but the architecture will remain the same. Okay, it's a two-way communication. The LLM will decide what has to be done, and an LLM should be there. A list of tools are needed. Okay, and on top of that, there's also an additional layer that's called as memory. LLM should also have the concept of memory, right? Imagine if I'm saying to the LLM, go to my desktop and create a folder. Okay, so LLM will create a folder. And if I'm saying delete the folder that you have just created, now for that purpose, LLM need to remember what was the folder that it has created earlier. So every request you are sending is not an individual request, because otherwise model will forget whatever is just being said earlier. So the LLM should have the concept of memory as well. Because of memory, LLM has the option that it can track, like along with this LLM, I also need to integrate somewhere over here or somewhere on top the concept of memory. So that whatever chat is being happening, whatever model is thinking, model is deciding, everything should be stored in memory. And if I'm going for a longer conversation, the model can decide, or model can remember that this was the last question where the user asked me to create this folder and user is now want me to delete this specific folder. Okay, so memory is also a very important concept. Okay, so in Agentic AI there are three main concepts: the LLM, the tools, and memory. Okay, and to create tools, for example, how will you search the link? Do I need to create tools by myself? Or for scraping the link, do I need to create tools by myself? If I'm creating tools by myself, so shall I share it with people so that no everyone should create their own tools? They can reuse the tools as well. Okay, and that is something is easily done by the concept of MCP. Okay, there is a new terminology I'm coming up with. Obviously there are a lot of terminologies we have discussed today, but you need to understand them. It's not going to be easy. Okay, you need to understand how all these things works. Okay, so in MCP is a way that can standardize all the things, right? And through MCP, like why MCP, there are a lot of companies who have built their own same kind of an architectures. They have built their own MCP servers. So what I can do, let's suppose if to an LLM, I want the LLM to search LinkedIn, and after searching LinkedIn, whatever post the user has, I have posted, I want to save all of them in MongoDB. Okay, and not only save it in the MongoDB, Some of them, some of the data I also want to share in MySQL. Okay, and eventually whatever is being done, I want to save the whole summary into GitHub. This is a complex problem. First of all, I need an advanced model, advanced reasoning model. Okay, and second thing is, am I going to manually write the function for MongoDB, like connect with it, run query, or disconnect? Or for LinkedIn, connect, post, update, delete, connect, reschedule, disconnect, or something like this? I'm not going to manually make them. Otherwise, it would be very difficult, right? To make one single project, it will take me literally weeks or months because I need to define hand code a lot of these things. So what we can do, like if we can have companies building their own MCPs, right? For example, LinkedIn will share their own MCP. They'll say, okay, this is the MCP that you can use. Okay, or like this is the link of the MCP that you can use. And if the user is saying now post on my LinkedIn about this thing, so we can post it. But for that purpose, you need to first of all authenticate through the API key, through the connection, auth connection that you need to make. You cannot write like post on my friend's LinkedIn on my behalf to do this. It cannot be done, right? So what MCP has brought into picture is every company, every organization can build endpoints, can build MCP server for their use case. And we as a developer can use their MCP server for easy communication in English language. We don't need to remember which function they have defined. Let the LLM decide it, right? So all these things are connected with LLM through the MCP. We are importing the MCP of all of them. Okay, and let the LLM decide which one we should be using. So if I'm saying this to this LLM that create a folder, and inside that folder write all the content of, let's suppose, 10 pages on Gen AI, and after writing it, save it, the main keywords, save the metadata in MongoDB and some of the data in MySQL, and eventually write everything and push it on my GitHub, and a summary of that, post it on LinkedIn. This is the query that I have given. Now to the LLM I have given this query. LLM will decide on its own to do the whole thing. How should I break it down to multiple steps? And to break it down to multiple steps, which tools do I have the access to? And if I'm asking it to go to my LinkedIn, my Instagram and post it, I have not given the access of that of Instagram. So it need to go back and get back to the Instagram again, right? So eventually, for everything, there are companies who have built their own MCP servers. I don't need to define the servers by myself. I can just import their servers. That's it. I just need to define this is also the tool that my LLM can use. So it's on the companies. I don't need to build it. Okay. What I can do is do the integration all of them, and that too with very minimalistic lines of code. And all I need to do is just tell the LLM to do all the work for me. All the coding editors, be it Cursor, be it Windsurf, be it Copilot, be it Anti-Gravity, all of them are using the same kind of architecture. Okay, they have the option of MCPs. You can import MCP of any of the things. For example, there are very less number of people who might have used it, but there is a MCP of model context 7. Okay, so if I'm asking ChatGPT, tell me about the recent updates that are being done on the recent update of Crew AI, so it might not able to give me the correct answer. But if I'm using context 7, it has the ability that it can directly go to the documentation of the codes, scrape out those documentation, and based on that, it will give the answer. So it can give you a much better answer, multiple times better answer than the traditional API call if I'm directly doing to the model, being same content given. Okay, it's not about if the content is different or not. Content is still the same. Only thing is, here we are adding some extra context. Even for the same model, if I'm asking a direct query or giving the whole context, this one can give you a better answer. Okay, so to summarize everything that we have done, like we have, like these were the main four questions that we supposed to discuss, and it's almost an hour since we are discussing about all of them. In the beginning, I was thinking they are very less number of questions. We just have four questions, so how can I stretch it? But still, there is a lot of room to understand more. I have abstracted a lot of things. We have not discussed anything about how embedding works, but that's also something that you need to understand. Okay, so to summarize everything, AI is in general any sort of intelligence we can put in machines. They are AI algorithms. Okay, they can or cannot be generative. So in generative, we have algorithms that can generate something new, not like traditional AI algorithms that can predict your next step. Probably stock price, probably next movie you are going to watch, product you are going to buy, next step you are going to take, next ad you are going to watch. All these things are predictive in nature. But using generative AI, we have algorithms that can generate something new. But to generate something new, we obviously require a lot more data. Okay. And the data is multiple times, hundreds of times more than the one that you might need to build a predictive model. Because for predictive model, less data is needed, less creativity is needed. You can easily distinguish this is the image of a male or a female. But to generate image of a male and a female, you need an artistic mindset, a lot more data, lot more time, lot more creativity. So that's why building generative models is computationally really very expensive. It will take a lot of time, lot of data. Now, the second thing is to build generative models, they use an architecture called as transformers, but there are a lot of other architectures as well. Okay, and in transformers, the mechanism is called as attention. So you need to understand how attention works, how transformers are built, and how all these things are trained. So you need to at least go for the main research paper of attention by Banu, and all you need, attention is all you need by Google, right? This is where they have introduced the architecture of transformers. If you want to go for some additional sources, you can also go for GPT 1, 2 and 3 paper. There were old days when open AI was actually open, but now we don't have models coming in, or model data card coming in for the recent models. Now, how do LLM works? We have also discussed, like LLM is not Gen AI. LLM is just a part of Gen AI. Okay, there are a lot of other things apart from LLMs in AI as well. In LLMs as well, we have different kind of modalities. Modality means type of data it can take or return. For example, text to text. Traditional LLMs approach is single modality. Text to image, dual modality. Text to image to audio, text to image, or let's suppose text or image to text. So it's again dual modality. So now companies are moving towards omni modality, where you can give any type of input and you can get any type of output from one single model. Okay, so this is LLMs, how they works and what are the different type of them. Okay, then we have discussed about RAG. When to use a RAG? RAG is something that we need to use if I want my answer to be among my knowledge base. Knowledge base means my existing articles, my existing books, my existing content. I want only to get the answer among these things. I don't want to get a generic answer. Then you can use the concept of RAG. But to get into the technicalities of RAG, you need to use which chunking technique you need to use, which document ingestion pipeline you need to use. Are you going to, for example, an article, we also might have images. How will you process them? We might also have some audios. How will you process it? So everything need to be taken care. And after that, which chunking technique you are using, which embedding model you are using, as are the embeddings great or not? What how will you evaluate if your embeddings are good or not? And eventually, how many chunks you have made, in which database you are saving it? Is it a chroma db, or which kind of vector db you are saving it, or which specific vector db you are saving it? How you will save the caching? What is the latency? Okay, all these things you need to defend if you want to make a scalable impact. Okay, and when not to use it, if your knowledge base is very small, probably just one pdf, you don't need to go for a RAG based system. You can go for a vectorless RAG that we have just discussed. Okay, and then What is agentic AI? Agentic AI is just the LLMs given some extra access. The LLM can write on your file, search the internet, search LinkedIn, search GitHub, or post on your LinkedIn. These are the additional access I'm giving to the LLM so that an LLM can behave differently than the ones that we have just said. Okay. Now just take one more minute so that I can see if you guys have any question or not. Otherwise, we can wrap this thing up. So if you guys have any question, do let me know in the chats. Why can't now that connect to the LLM again? Okay, so they are also connected in that case. If you're talking about this approach, why are not why they are not connected? They are still connected. We can add that specific approaches here as well, but this is just a simple architecture. I don't want to add too much things, but I can also add one more option here where the LLM can search the internet. Okay, so now the LLM can also decide like to post on LinkedIn, which tool I need to use. And if I'm saying like search the internet for recent AI news and then post it on my LinkedIn and save the metadata in MongoDB and save the important data, let's suppose, in relational database MySQL, and eventually save everything in GitHub. So now it need to call all these 5 agents or all these 5 MCP servers. So this is how it need to be done. So LLM will decide first of all the searching of the links, then scraping the data. After scraping the data, it might be refining all that content for MongoDB, saving the cache, and LinkedIn, and all the other flow. Okay, so this is everything that we have discussed. I hope that you will crack for sure the TCS NQT interview. And if you still have any doubt, any question, anything in your mind, make sure to write it in the chats. I'll be more than happy to answer queries. Go ahead, prepare well, and I'll see you in some other lecture. Take care, everyone. Thank you so much. Best of luck.